Imagine a time when Earth was a seething ball of fire and chaos. Picture a world where the surface was a molten inferno with volcanoes erupting incessantly, spewing lava and gases into the atmosphere. This was the Earth in its infancy, a planet in the throes of violent transformation. Curious to know how it became the cradle of life. How did this fiery, chaotic world evolve into the blue and green planet we call home, teeming with diverse ecosystems and life forms? 4.6 billion years ago, Earth began as a swirling cloud of gas and dust around a newborn sun. This nebula of vast and turbulent cloud was the birthplace of our solar system. Over time, gravity caused these particles to coalesce, forming the early building blocks of planets. Gravity worked its magic, pulling particles together to form a molten planet. This process, known as accretion, saw countless collisions and mergers of smaller bodies, gradually building up the mass of the young Earth. The heat generated from these impacts, along with radioactive decay, kept the planet in a molten state. Intense collisions, including one that created our moon, shaped its early form. This colossal impact, known as the giant impact hypothesis, suggests that a Mars-sized body collided with the young Earth, ejecting debris that eventually coalesced to form the moon. These early impacts played a crucial role in shaping the planet's structure and composition. In its first 500 million years, Earth was a fiery, volatile world. The surface was dominated by volcanic activity with magma oceans and frequent eruptions. This period, known as the Hadean Eon, was marked by extreme conditions that would seem inhospitable to life as we know it. Volcanoes spewed lava and gases, creating a primordial atmosphere. This early atmosphere was vastly different from what we breathe today, composed mainly of water vapor, carbon dioxide, nitrogen, and trace amounts of other gases. It lacked free oxygen, making it a hostile environment for most modern life forms. Slowly, the surface cooled, and water from comets and chemical reactions formed the first oceans. As the planet's temperature dropped, water vapor in the atmosphere condensed to form liquid water, leading to the creation of vast oceans. These early bodies of water were crucial for the development of life. Around 3.5 to 4 billion years ago, microscopic single-celled life forms emerged in these oceans. These early organisms, known as prokaryotes, were the pioneers of life on Earth. They thrived in the nutrient-rich waters, laying the foundation for the complex web of life that would follow. Through photosynthesis, they began producing oxygen, setting the stage for more complex life. Cyanobacteria, a type of photosynthetic microorganism, played a pivotal role in this process. By converting sunlight into energy and releasing oxygen as a byproduct, they gradually transformed the atmosphere, paving the way for aerobic life forms. 540 million years ago, the Cambrian explosion saw an incredible burst of life in the oceans. This period marked a dramatic increase in the diversity and complexity of marine organisms. Fossil records from this time reveal a wide array of life forms, including the ancestors of most modern animal groups. This event marked the rapid evolution of the ancestors of most modern animals. The Cambrian explosion was a pivotal moment in the history of life, leading to the emergence of complex body plans and new ecological interactions. It set the stage for the rich tapestry of life that we see today. Earth's crust, divided into tectonic plates, has been in constant motion, forming supercontinents like Pangaea and shaping our geography. The movement of these plates, driven by forces deep within the Earth, has caused continents to drift, collide, and break apart over millions of years. These movements influenced climate and ecosystems. The shifting positions of continents have altered ocean currents, wind patterns, and climate zones, leading to changes in habitats and the distribution of life. Geological events such as volcanic eruptions and mountain building have also played a role in shaping the environment. Earth has seen 5 major mass extinctions, the most famous being 66 million years ago when an asteroid wiped out the dinosaurs. These catastrophic events have had profound impacts on life, causing the extinction of many species and opening up opportunities for new forms of life to emerge and diversify. These events reshaped life, paving the way for mammals and eventually humans. After the extinction of the dinosaurs, mammals began to diversify and occupy new ecological niches. Over millions of years, primates evolved, leading to the emergence of early human ancestors. Humans arrived around 300,000 years ago, dramatically altering landscapes, biodiversity, and the climate through agriculture and industrialization. The development of agriculture allowed humans to settle and form complex societies, while the Industrial Revolution brought about rapid technological advancements and environmental changes. Despite these changes, Earth remains resilient and dynamic, evolving with each new challenge. The planet has a remarkable ability to recover from disturbances, whether they are natural or human-induced. Ecosystems adapt, species evolve, and new forms of life emerge, continuing the cycle of life. So what's next in Earth's incredible story? Only time will tell. As we look to the future, we must consider our impact on the planet and strive to live sustainably. The choices we make today will shape the Earth of tomorrow, influencing its landscapes, climate, and the diversity of life it supports.